Thank you for, God bless you for reminding me. Thank you. Uh, Hopefully we didn't get through too much at this point. But we just pretty much, we read out loud the highlighted part, and now we're just pretty much starting to solve that. I was gonna say equation. It's only an equation when there's an equal sign, but this has a greater than sign, so it's an inequality. Let's see. So we went ahead and subtracted 7 from both sides. Now x is all by himself, greater than, and then just like we would do with an equation, subtract 13 minus 7 would be 6. So the solution would be x greater than 6. Yeah, but you can leave it like that, but that really means, yeah, x greater than 6. So unlike with equations, if this was an equation, if that was instead of a greater than sign, or yeah, if it was instead of greater than, it was equal to, then the answer would be x is equal to 6. That's only one solution, but here it's kind of interesting. When it's an inequality, you actually have infinitely many solutions. X is greater than 6, that means any number larger than 6 would fit the bill. So there's infinitely many answers to this inequality. They're all numbers that are greater than 6, and there's quite a few that are greater than 6, right? So that's a big difference between equations and inequalities. In one, you're going to have infinite solutions, and one, you're only going to have maybe one. In the future, we might see multiple, but not infinite. Anyway, maybe that's going too far and making it's too early for all that talk right there with infinity and stuff. So now we'll look at another one. Suppose we're given this kind of more interesting one, I guess, or not everybody's favorite because there's a fraction, but 1/4 x is less than 2. So maybe we'll look at that. Okay, 1/4 x less than 2. So that one, you can think of it two different ways. I want to solve that. So I kind of like the last one. I'm going to imagine that the less than or the greater than sign, whatever the inequality symbol is, imagine it being an equal sign. What would I do? Well, I see that the 1/4 is being multiplied by x. So I could divide both sides by 1/4, but I can imagine that gets really messy. Then on the right side, you'd have 2 divided by 1/4, which isn't super awesome. So I'm kind of just imagining that. Imagine if I were to divide both sides by 1/4. Then the left side would be fine. And the spoiler alert is that this is probably not the best way to do it. So right now I'm just imagining what it would look like, and then I'm going to say, no, I don't think I want to do it this way. 2 divided by 1/4. It's not really pretty. I mean, it's possible you could still do it. If you remember, you just flip and multiply. When you're dividing by a fraction, it ends up being you're multiplying by the reciprocal. So I do 2 times 1/4 upside down. Oops. Upside down would be 4/1. But I don't know if that's a lot of thinking involved. I would just say blanket rule: whenever you have an inequality equation an inequality you're trying to solve, or even an equation you're trying to solve, and there's a fraction coefficient, I would say the best way, instead of dividing by the fraction, multiply by the reciprocal of that fraction, which just means imagine it upside down and multiply by that. That's kind of an easier way to get rid of that fraction. So I'm going to kind of write that down in case you want to make note of that. If you already knew that, then don't worry about it. Just ignore me for a second. If you have a fraction coefficient, and coefficient, this just means the number that's in front of x or the variable being multiplied. Fraction coefficient, get rid of it by multiplying by the reciprocal. It's just easier. It takes less time, and yeah, of it by multiplying by its reciprocal. Multiplying by it's a word we don't use very often, but reciprocal, all it means is that fraction upside down. So that's what I'm going to want to do. I could do it, yeah, the way we did it in this red kind of thought bubble, but it seems like it's not so bad this time, but it might be bad in the future. It might be nastier for different examples. So I'm kind of taking up a lot of room here, but I'm going to take this over and then do it the way we described. I have 1/4 x less than 2. And like I said, this would be true if this was an equation as well. If it was 1/4 x equals 2 or greater than, less than, still I would do the same thing. I'm going to multiply by the reciprocal. And like we said, the reciprocal is just, imagine that fraction upside down. It'd be 4/1. But as a lot of you know, 4/1, anything over 1 is just that number. So there's not really a need to write that over 1. You can just write 4. But yeah, it's up to you how comfortable you are with that. Which now it's kind of clear why that's a good idea, because I see on the left side, when you have 2 fractions multiplied, you can cancel along diagonals, or you can cancel vertically. So those 4s will cancel. It just ends up being a 1 times x on the left, or you could just write x. That's what we'll simplify it to. And then on the right, I should put the 2 over 1 because I can't multiply a whole number by a fraction. I have to think of it as a fraction times a fraction, but that would end up being 2 times 4, which is 8. Oh, technically over 1, but like I said, I know anything over 1 is just that thing. So the left side just simplifies to x because it's 1 times x, and the right side simplifies to just 8 because 8 over 1 is just 8. So that I would have got that if I did it the way we saw here in this red thought bubble, but it's just easier. I think that's a good way to remember it. If you're solving equations or inequalities and there's a fraction multiplying by the variable, that's probably the easiest way to get rid of it, I think. Yeah, hopefully that makes sense. I mean, you could do it the way we did it in the red thought bubble, but I think someday you'll end up with something terrible and you'll say, man, I should have done it that other way. Probably. So that we're all done with that one. Just going to move on to the next example, but before we do you have any questions about that one? It didn't look bad, just a nice simple little inequality, 1/4 x less than 2, but it ended up being not super nice. Okay, hopefully that was helpful to someone. Hopefully not everybody already knew that, so it was actually helpful. But let's see. Now I think in the next example we're going to look at down here, it shows, oh, I don't have my drawing on. Let's see, this guy. It shows an example where there's one rule for inequalities when we're solving an inequality. Like I said, you can kind of imagine the inequality symbol, the less than or the greater than. You can imagine it just like an equal sign, but there's one special situation where you have to remember to do something. And this example will have to do that. So maybe I'll kind of write a note to the left side of it here, where hopefully we have room. So you would just solve an inequality just as if it was an equation. But let me write that little rule that we might need. Let's see. So let's see, while solving an inequality like this, where, yeah, you may have it greater than, you may have it less than. If you ever divide or multiply, both sides of the equation, or both sides of the inequality, I should say. Of the inequality, that's a lot of words, sorry. Inequality by a negative number, by a negative number, just in the course of you solving, as you go, you know, like I said, solve it like it's just an equation, imagine it is. But if as you're going, you ever have to divide both sides by a negative number or multiply both sides by a negative number, you have to flip the inequality backwards. Flip the inequality symbol. So, you know, that means if it was a greater than, you change it to less than. If it was a less than, change it to greater than. So that's kind of tricky. It's something it's hard to remember, but it's very important. But that's, other than that, one very important rule: solving an inequality is pretty much exactly the same as solving an equation. It's just, you have to kind of keep track in the back of your mind as you're solving it. You're pretending it's an equation. Okay, pretend that's an equal sign. How would I solve it that way? But let's just say, okay, let me keep track of, if I ever multiply or divide both sides by a negative number, then I got to remember to flip it. If it was this way, go this way. If it was that way, go that way. Yeah, it's really easy to forget because there's just so many rules in math. You know, just one of 100 that you might forget. Oh my gosh. So with that in mind, let's grab this guy, this equation, and, or sorry, I keep saying equation, and the whole name of it is inequality. Hello. So I want to solve this. I'm just going to pull it off to the side and try to solve it. There's -2 times parentheses x minus 5 less than 10. Okay, -2 parentheses x minus 5 less than 10. All right. So like I said, it's kind of, it feels like, I don't know, it feels like a delicate equation or inequality. Like, what can I do to this? Because there's a less than. But just imagine it's an equal sign and just do what you would do. I guess there's multiple ways you could do this. I could distribute this -2 in here and then solve for x. That would be fine as well, because you would get the right answer. But I think what they're saying on this example is they want to get rid of this -2 right away. You can, if you want to, you can divide both sides by -2 just to knock it out. But like I said, if you were to distribute the -2 and then solve it from there, you would get the exact same answer. So that's the good news. As long as you follow the rules, you could do the steps in different orders and you still get the right answer. Just along the way, it might look different, but it'll get the right answer. So in this case, we divided both sides by a negative number. So on my next step, I'm going to simplify the left side. Okay, the negative 2 is gone. The right side, 10 divided by negative 2 is negative 5. But now I have to flip the inequality. So it flipped backwards. It was a less than, now it's a greater than. If it was if it was a greater than, I would change it to less than. So very, very tricky, I think. And whenever there's an inequality on a midterm or a final, and that's the mistake. That's like 90% of mistakes are that someone forgot to flip the inequality. But once you do that, now you're home free. I'm just going to move the 5 over so that the x is by itself. And it looks like on the right side, it just combines to make 0. So it looks like our answers are x is greater than 0. And there are infinitely many answers in there. Anything bigger than 0. So in other words, anything positive, the answer could be a half, it could be 1, it could be 3/4, it could be 100, it could be 1,000,000, it could be, infinitely many answers, which is kind of, it's pretty amazing. There were infinitely many answers and we found them all. But like I said, if you were to do it the other way, just to show, I mean, I don't know if anybody's interested, but I feel like the instinct in this one would be to distribute, because usually, when you see something that's something multiplying in front of parentheses, you're always told to distribute. So that's our first instinct here. And that's just a different way you could do it. Let's just try it that way, just to make sure. So I think some people maybe don't believe me that we'll get the same answer. If I distribute the negative 2, let's see, our terms will become negative 2x, but then it's negative 2 times negative 5, so it'll be positive 10, that less than 10. And I haven't, even though I kind of multiplied by a negative there, I didn't actively multiply or divide both sides of the inequality by a negative. I was just simplifying one side. I didn't, act on both sides to try to solve it. So that's no need to flip it yet. But the next stage, I guess at this point, I would probably subtract that 10 out of there. Because like we said last week, you want to get rid of terms in the reverse order of operations. So if something's multiplying by the x, that's the last thing I want to do, because there's something adding with x. I move the 10 over. Okay, that would mean negative 2x is all by himself on the left side. I still haven't, even though there was some kind of negative going on, I didn't multiply or divide by a negative, so I don't have to flip it still. But on the right side, 10 minus 10 would be 0. And now the very last step would be, now I'll divide by the negative 2. And we'll, of course, get 0, because 0 divided by anything is 0. Let's see, so x is all by himself on the left, but now I got to remember that I divided by a negative, so I flipped the inequality. That's the hardest part. So either, and the way we did it first, I flipped the inequality right off the bat because I divided right off the bat. But this other way we did it, I divided last, so I flipped it last. But either way, you get the same answer. You notice x greater than 0. So no matter how you do it, like I said, as long as you follow the rules, the steps could be in, different order, but you're still going to get, the right answer. So hopefully that clears up any questions about inequalities. But I think that's pretty much it. Other than the whole, you have to flip it if you multiply or divide by a negative. Solving an inequality is exactly the same as solving an equation. That's the only difference. Yeah. So you know what I forgot to say? I don't know if you care or you noticed, but the top of the first page that we started on here, it has it looks like the leftovers of some other topic. So we're not doing that. Don't worry about this. Your turn. It's like a word problem. I thought about last week doing that, but I don't know. It's not really important for this class. I think if you have to take pre-calculus, you might do this in there. But for Math 111, I don't think it's not super important. So I'm just going to skip it for now. Yeah, kind of do what's important for Math 111 material. Oh, sorry. I see Jenny. Do you have a question?
Yeah, what was the rule about doing the PEMDAS backwards that you just mentioned?
Oh, was it last Thursday?
I remember you mentioned it.
Yeah, when you solve equations, they call them linear equations, but like the ones that we did last Thursday, when you solve equations for x, and I guess the idea is there might be multiple things you have to move from the side x is on to the other side, and it has to be done in a certain order. So you have to move, not terms. What do I want to say? Move numbers, I guess, just in general, numbers to the other side of the equation. Side of the equation. In reverse order of operation. And I think it said that in the worksheet, or the portion of the worksheet that we actually did on last Thursday. Reverse order of operation. And I think if you've done a lot of solving equations, and it's almost like second nature. You just know instinctually what to move when, like the one that we were looking at just there. even though it's an inequality, it's still just the same for equations. But if you had what did we have up there? Negative 2x, is it plus 10 or minus 10? Whatever, something like that. 10, and it was less than 10. But it's true for equal sign too, so I can change it to equal. But I know if I want to get x by itself in this equation or this inequality, whatever you want to call it, there are two things that need to move. I need to move this negative 2 because he's preventing x from being by itself, but also this 10. So I need to move both of them, but if I move them one first and then the other, it has to be done in a certain order. So, you know, what we did on Thursday, the order of operations, it was PEMDAS, parentheses. So that was the first thing we do when we're just simplifying an expression. We're not trying to solve, there's no equal sign. It was just a big expression with numbers and parentheses and exponents and stuff. What's the order you have to kind of simplify it in? This was the order. It was exponents next, and then multiply, divide. Those are on the same line. You kind of look from left to right, multiply, divide. And then the very last thing, if you were simplifying an expression, would be add or subtract. But when we're moving terms over in an equation, not simplifying it in expression like we did on Thursday, but now we have an equal sign or a greater than, we do it in the reverse order. So now if I want to know what to move to the other side to start isolating x, I would do anything adding or subtracting needs to move first. So that's why I definitely moved the 10 first. I got rid of him, get out of the way. And then once he's done, the next thing I would do is, well, anything adding or subtracting, I moved. The next thing in reverse order of operation would be anything multiplying or dividing. And this negative 2 is multiplying. So he needs to move next. And then if there was an exponent on x, which we're not going to look at yet, I think in the future in Math 111, we'll see that. But if there was a power on x, like a third power, that would be what you would move next. Somehow get rid of that. We'll kind of talk about that in the future. And then very last would be if there was anything in parentheses, like if it was x plus something in parentheses, you kind of move everything that's outside the parentheses first and then focus on what's inside. So that's, yeah.
Thank you. I totally remember now that you've said it. It's just not quite instilled in my brain yet because it's been so long since I've taken math.
Oh, that makes me feel better though, that this is actually helpful for someone. Good. I was hoping this was helping somebody. Good.
Thank you.
Yeah, thank you for asking. I'm glad. It's kind of, yeah. I think just after you do a bunch of solving equations, then it just becomes second nature, you know? So if someday you became a tutor for math and then the person you were tutoring said, so why do you move, like in this example, why'd you move the 10 first and then the negative 2? You just say, just because that's what you do. And you kind of forget why. It's kind of like instinct, but that's why it's supposed to be the reverse order of operations. It's just funny though. I think some people they become, or they naturally are good at math. And then when they try to explain it to someone, they're just like, I have a hard time explaining this because it is the way it is, okay? But it's good to know why, because it's easier to remember the steps if you remember why. Yeah. So I think that's probably all you really need to know about inequalities, I think. We'll see some of those in Math 111, just kind of here and there. We're not going to focus on them super a lot, but when you do see them, that flipping the inequality every time you multiply or divide by a negative, that'll mess a lot of people up because it's just a little tiny detail you see maybe one day in a math class and then you don't see it again for years. And then they say, how could you not remember that rule? Well, because I never use it in real life, okay? How am I going to remember that? Okay, anyway. So linear equations now, this is not solving equations. Like on Thursday we saw, here's an equation, it has an equal sign, but it just had one variable like x, and I had to isolate it. But now linear equations we're going to talk about here, that's where you have two variables, an x and a y. You know, something, they have kind of a general form here. Wait, oops, let me try to circle it or highlight it or whatever. Dang it, sorry. Come on now. Here it is. That's what it looks like, but that looks just looks like a bunch of letters, but just an example of it might be, you have y equals 3x plus 1 or something like that. That's what they'll look like. So it's not possible for me to solve that because I have two unknowns. I don't know what x is, I don't know what y is. So what do? I can only solve an equation if there's one unknown variable, but since there's two, that's kind of why we just graph the line, because I don't know, I can't give you a solution. So I'm just going to graph this line that represents all the solutions. So that's really what a line is. It's just a graph that represents all the infinitely many solutions, x and y, to this equation, which is kind of wild, right? I think when I was a student, I always wondered, why are we graphing lines? Why? What does that do? And that's pretty much it. This equation and any other equation like it with the x and a y, there are infinitely many solutions. X is some number and y is some other number. And I can't really just write them all out. There are infinitely many. So the best I can do is just draw a picture of it. Hey, you see that line? Every point on that line is a solution. And that's pretty much why, which is kind of interesting. And I know there are applications in real life for these things that we'll see in Math 111, chapter 2 more. So anyway, that's enough of that. Let's just get down to it, huh? Quit babbling on, you know what I mean? Oh my God. So that's what it says here. Yeah, we have a linear equation. They call it slope-intercept form. That's what this guy's in, the one I wrote. And this maybe, review, you might already know it. You might have forgotten it. Just kind of depends. Let's see, why is my mouse having a hard day? There you go, little guy. My mouse fell asleep, I guess. The number that's in front of x, when it's in this form, where y is isolated, y equals blah, something with x. The number that's in front of x, the coefficient, is the slope. So it just kind of dictates how steep, I guess, the line is. The larger that number is, the steeper it is. If it's a small number, like a half or 1/10 or something, it's going to be a really shallow. Is that the right word? The opposite of steep is shallow. Something like that. That's what the slope represents. And then 1 or whatever this number is that's adding or subtracting at the end, that's the y-intercept. Whoops. Which just means that's where the line will intersect the y-axis. Where will it hit the y-axis? Does it already say that here? Yeah. Yeah, line. You might have already known that, or you might have forgotten it. Yeah. You don't use this a whole lot in real life. I don't know. I haven't had a lot of jobs in my life, but never had to use it except for teaching math, of course. The y-axis. Yeah, that's the idea. Let me see. I'm going to try to. We can try kind of draw a little XY coordinate system, because even that might be something that you forgot or you never learned, or who knows. It just, yeah. I think when I went to high school, I passed math, like algebra and even pre-calculus. But then when I went to college, I realized I didn't learn anything in those classes. So I think a lot of people, maybe I don't know if you're in the same boat or similar, where all this stuff is supposed to be review and you're like, wow, my high school did not prepare me for this. Yeah, then I understand. But anyway, so that this guy right here would have y-intercept 1. So on the y-axis, there's 1. I won't go into specifics yet about how to graph it, but it looks something like that. So the slope, I know it's kind of steep, which is a relative term. It's kind of steep because the 3, and it intersects the y-axis at 1. So that's kind of the idea behind it here. Yeah. But we'll do more examples here. Maybe I'll come up with another one. But I guess the y-intercept, that part's not too difficult. You just find that number, whatever's adding or subtracting on the right side of x in your equation, that's where you put a point on the y-axis. The slope is kind of harder. Okay, now that I've got that 1 point, the y-intercept, now what do I do? How does the slope help me find another point, Because to figure out what the equation of a line is or how it looks, you have to have at least 2 points. I have to know 2 points. The first one is the y-intercept, but the slope will tell you what the next one is. And to do that, you'll have to think of it as rise over run. So I guess any coefficient of x in these will, like I said, it'll represent the slope. But even if it's not a fraction, like the one we wrote, that example, the 3x plus 1, obviously the coefficient of it is 3. But I'm supposed to think of it as a fraction. It's not a fraction, but I can create a fraction out of any whole number by writing a 1 underneath it. Because we've seen that before. If I simplify 3 over 1, that's just going to be 3. So I kind of go backwards. I'm going from a simplified version of 3, and I'm writing it more kind of they're kind of more complicated, but at least it has meaning. So the 3 represents the rise. Whatever the numerator is represents rise. That means I'm going to go from that y-intercept, I'll go up 3 units from there. Rise, I guess, it's kind of misleading because rise, it makes it sound like you're always going up. But if that was a negative number, if it was a -3, I'd be going down. Right. So rise really means I go up or down, depending if it's negative or positive. Positive, I go up. And negative, I go down. And then it's kind of similar for the denominator. That represents the run, as it says here, which I don't know why they use that word. It's not super descriptive, but run, that means you're going to go left or right, depending if that value, that number was positive or negative. On the x-axis, going to the right is the positive direction. So if my value there, 1 in this case, is a positive number, which it is, I'm going to be going to the right that many. But if it was negative, I'd be going to the left. Okay, so that's a lot. That's a lot. And I think after this, we'll try an example where it's a negative number too, because that's kind of tricky. I can't remember if it's this class or a different class, but I got an email over the weekend and someone asked about, if the slope is negative. Someone was way ahead in the homework, obviously. But, how does that look and what can you do as far as the slope? So maybe after this, well, yeah, we'll look at one of those. But I would always start at the y-intercept. So I'm going to put a little point at 1 because I know my y-intercept is 1. And then from there, I'm going to rise 3 and run 1 because that's what we said the slope was down here. 3, rise. So from that, not from the middle, not from the origin, but from that point I put, I'm going to go up 3. 1, 2, 3. And I don't put a point yet. I still have to run 1. Because they're both positive numbers, I go up and to the right because those are the positive directions on the x-axis and the y-axis. And now I put a point. And that's all you need, 2 points. So I'll just connect them and just kind of extend it, try to make it look as straight as possible. But, when it's on it's on paper, it's hard to make it look straight. That's pretty much it. Yeah. But maybe we'll look at an example now where the slope is negative and maybe the slope is also a fraction already. This one, it was a whole number, so we had to force it to be a fraction by giving it a denominator of 1. But what if it was already a fraction? Maybe we'll see that. If we want to graph about y equals negative 2/3 x minus that 4. I don't know. I'm just making it up as I go, obviously. Okay, so I'd identify the parts. The numbers here, the y-intercept is going to be 4, y-intercept, and I don't really know why they call it b, the letter b. I don't know if it's true, but someone told me that y-intercept in, I can't remember, some language, was it German? Starts with a B, and that's why, I don't know. I think that's a bullcrap. Someone lied to me, but for some reason they call it b, I don't know. So the value of b is it's just the number that's adding or subtracting at the end. It's a 4, but I also have to keep the sign with it. So it's not just a 4, but it's a -4. So I'll start on the y-axis at -4, okay, when I graph. But also, I might as well identify the slope as well. Same, maybe M too. Why does M represent slope? Why not S for slope? I don't know. Just hundreds of years ago, someone came up with it, and we all just stuck with that rule, I guess. So the slope is negative, and now I think this is the question someone asked. Why? I think they were doing homework, and they clicked on the help me solve this, and then the way it was explained, the student said, well, why did they put the negative sign in the numerator? Then I answered them and I said, well, technically you could put it in the numerator or the denominator. So if you wanted to make the 2 the negative and 3 the positive, that's fine. Or you could make the 2 the positive guy and the 3 the negative. Either way would work, and maybe we'll see why. But I think the question they were wondering is, why don't you put a negative on both? If I put a negative on both, make the 2 negative and the 3 negative, as we've seen before, a negative divided by a negative is a positive. But really, I started out with a negative fraction, so I shouldn't put the negative on both. It has to be one or the other, or else I'm actually changing a negative to a positive. Yeah, if you kind of create an extra negative sign out of one negative sign, you change it to 2 different ones, you're actually changing it from a negative to a positive. So that's why I don't want to put it on both. You put it on one or the other. It doesn't really matter which. I think just to simplify, I always just put it on the numerator, just so I don't have to think about it or make choices. I don't like choices in that. Just tell me what to do and I don't have to think about it. But either way, it should work. Okay. So we got the slope, we got the y-intercept. All right, let's see. I'm going to start with the y-intercept. That's what we always want to do. And 5 minutes ago, I said it was -4. Okay. So on the y-axis, that's the vertical axis, I'm going to go down to -4. There he is. Oh, make a point. Come on now. There we go. Okay. So we got 1 point. We only need 1 more to connect them and create the line. And the slope should do it. So I know the slope is either way you want to think of it, but I always just put the negative on the top. Rise. So the numerator is how much you're going to rise, which is your vertical. I'm either going up or down. And then 3 is what I'm going to run, which is either left or right, depending if it's positive or negative. So the 2, the rise is negative. That means I want to go down because down is the negative direction. So from there, I'm going to go down to here, but I'm not going to put a point yet. I still have to run. And if I'm thinking of it as the -2 over +3, I'm running +3, which is to the right. So somewhere around there. If you're doing this too and your line doesn't look quite the same, it's probably just because I spaced my coordinates a little weird, or you made them bigger or smaller than me, or something like that. But it should be something to that effect. And just if you're curious, I know some people don't even care, so just ignore this part. But if you were to think of it as the +2 over -3, then you would be rising +2 from that y-intercept, which means you'd be going up actually in the opposite direction, but then you'd be going -3, that'd be to the left, 1, 2, 3, and you should, you might land on a different point, but you're actually still landing on the same line. So putting the negative in the numerator or the denominator, even though it gives you a different second point on the line, it's still giving you the same line, so it doesn't really matter either way. Yeah, what matters is the line. I don't really care what the points were, I guess, as long as the line's correct. So kind of interesting, yeah. The one thing I guess to point out here is that if you have a positive slope, like, it's just a positive number. Like in the first example we did, it was +3, then it'll be sloping, I guess, upward from left to right, if that makes sense. If I'm looking at this line from left to right, it's going up as I go. But if it was a negative number, like in this one, -2/3, negative slope, and it would be going down from left to right, like that. Does that make sense? So I think it's kind of good to keep that in mind, because if you graph the line and you make a mistake somehow, then you can kind of check at the end. Now that I look at my graph, I should see it going downward from left to right. That's good, because I had a negative slope. That kind of helps you check if you did it right. It's going down from left to right. Also, it's intersecting the y-axis at -4. Yeah, that's okay. So I probably did it right. Yeah, I think. Yeah, hopefully that makes sense. So like I said before, please stop me if you have any questions. It's kind of a lot to take in, whether it's a brand new thing and you've never seen this, or it's review. Still, it's a lot. Unless you remember it all, then that's awesome. Then you're lucky, I think. Now, the next thing that they talk about here, I just kind of made up the examples we just did. It was already in that slope intercept form where y is by itself. It's y equals the slope times x plus or minus some number that's the y-intercept. But what if it's given to you in a weird, different kind of form, like in this one, what? No, I'm not trying to do that. Like this. So here, y is not by itself, but you still want to graph it. They say, okay, go ahead and graph this line. But I say, but y is not by itself. So I don't know. Honestly, I can't tell what the slope is right now. Even though the coefficient is 3 on x, I think if I were to isolate y, the coefficient of x will change. So really, I can't say the slope is 3. I have to, like they said, you have to isolate y, which is kind of weird. It seems weird. It's kind of like you're solving, like we did on last Tuesday with equations, but with those ones, there was only one variable. Now there's 2, so it's kind of weird, but you can kind of treat x like it's a number. I feel bad. I kind of feel like I need to respect x, because I don't even know what it is, but I just throw them around with the other numbers, get out of here, x, go over there with your other friend. But I need to move. Okay, I want to get this guy by himself. So really what I need to do is get this 3x out of the way, somehow move him over to the other side, and also move this 2 over to the other side, or -2. But kind of similarly to before, I have to do it in the reverse order of operations. The 3x that's in the front, I want to move him. He's adding or subtracting with y. And then the 2 or the -2 in front of y, that's multiplying. So I think that should be the last thing I do. The reverse order of operations says I need to move whatever's adding or subtracting first. And it feels like I can't do that, but just think of 3x as one item. It's just one term. It's a positive number. I mean, because there's no negative in front. So I do the opposite and subtract it. It almost feels like I can't do that. That seems like cheating or something, but yeah, x is just some number. Just because I don't know what he is doesn't mean I can't throw him around. You know what I mean? That sounds kind of bad. That sounds violent or something. Anyway, there was a 4 on the right side. Usually at this point, I can combine like terms, the 4 and whatever I moved over, but I don't know what x is, so there's no way to combine those. I just got to put them next to each other. Okay. And then the last step would be, I see a -2 multiplying by y. I need to do this, the opposite of multiplying and divide. So, and it's probably, since there are multiple terms on the right side, it's probably easier to just divide every single term separately by -2, because it'll simplify easier rather than dividing the entire right side by -2. Just you're allowed to give every single term their own denominator or their own division by -2. Yeah, because that'll simplify easier. So what do we get then? On the left side, of course, -2 and -2 will cancel. So I'll just get y. And then this term here, it's +4 divided by -2. That'll be -2. And then we have a -3 divided by 2. That's not going to be a whole number, so I'm just going to write it as -3 over 2x. So that's, and all that is I'm trying to isolate y, so now I can identify the slope and the y-intercept in order to graph it. So unfortunately, if y is not by itself already, you have to kind of follow that process to isolate y, and then you can graph it using the slope and y-intercept. Oh, sorry, someone had said, you zoom out and show what you wrote down for. Oh yeah, sorry. That's a good idea. Let me zoom out for a second so you can see everything. Sorry, I wrote everything down and then it was like, okay, I hope you got that, and then moved on, but maybe not. Yeah, good idea. Let's leave it here so anybody can write down what they need. Yeah, no problem. I'm glad you asked. Thank you for saying that. Because seriously, if you have a question or yeah, something like that, where you didn't quite write something down in time or something, chances are it's not just you, it's someone else, but they're too shy to say it, or they're, I don't know, they don't want to ask. So I'm glad you did. Yeah, we'll give it some time, and then we'll take that. Oh, geez, sorry. We'll take that kind of new form of the same equation, even though that equation that we just solved kind of looks different. It's still the exact same guy in disguise. You know, what was the original one they gave us? It was 3x minus 2y equals 4 or whatever, something like that. This is still the same equation. It just looks different. Sometimes I tell my class, it's kind of like me when I go to Costco. I go to Costco and get a free sample. I'm like, ooh, that was good. Then I feel too embarrassed to ask for another one, so I disguise myself. You know, I put a hat on and sunglasses and say, excuse me, can I have a sample for the first time today? And hope that they don't recognize me. That's what this line's doing. He looked one way. He changed. He just put a little disguise on it, but it's the same line. Just to the observant eye, you might recognize that it's the same line. All right. If you want, if you're done copying this, you can try to graph that line if you want. We will actually switch those two terms around. I know usually we're used to the x on the left, y equals mx plus b. So I could switch those two terms. I'm going to write -3/2 x and then the -2, just so it looks more like what we're used to. Yeah, rather than having the 2 and then the, yeah. So we can kind of start talking about it though. From there, obviously, I guess the y-intercept is -2. That's, I guess, another mistake you could make on accident is just, I forget the negative. I'll say, oh, y-intercept is 2, and I'll put a y-intercept at +2, but don't forget that whatever sign is to the left of a number, that should follow it, and it's kind of part of its identity. Yeah, if there's a plus right in front of it, he's positive. If there's a negative, he's negative, and he keeps that. It's his, he owns it, I guess. Okay, so y-intercept is -2, and then the slope is just the coefficient of x. So we got slope is -3/2, and you see that just the way it's written up here, the negative is just kind of on the side. It's not really on the 3, it's not really on the 2, it's just floating. But you have the freedom to put it either place, but like we saw before, not both, just one or the other. I always just, like I said, so I don't have to remember or even think about it. I just throw it to the top and just keep going. Kind of like when you wash the dishes, you don't even think about it. You just put some soap on the sponge and just start washing. You could be half asleep, and yeah, it's just like part of the steps to do some process, and I don't even think about it. Just do it. Okay, I think from there, we should be able to graph this guy. And like we did before, we know we have to start with the y-intercept. Okay. I'm gonna draw. The good thing, I guess, is on the homework, it's a perfect graph. You kind of click on, I think there's an option, if you haven't seen it yet, maybe this is a good preview. When you're on your homework, it's digital, right? So like if they say graph this line, okay, I think next to the graph, there's options. Do you want this kind of graph, kind of a U-shaped parabola? And I'd say, no, that's maybe in the future in a different chapter, we'll be looking at that, but it should be an option for a line. They'll just show it like that. So I'll click on that. I'll say click, and then it'll be ready. And then I just click on 2 points on my graph, and then it'll create the line for me. So I would click on, of course, -2 for the y-intercept. I'd click on 1 point there, and then I'd have to kind of count. Don't click on a point yet, but count, rise over run. I'm going to rise -3. So that means down. Okay. And then run +2. That's to the right. So that's a positive direction. Okay. So from that y-intercept at -2, I'm going to be able to go down 3. Okay. 1, 2, 3. And I can see my spacing is so bad. Sometimes it's this far apart. Sometimes it's that far apart. Oh, well, down 3 and then to the right 2. Okay. Yeah, somewhere around there. That's pretty good. And then connect them. Yeah, but like I said, on the homework, you'll just click on this line, and then it knows you want a line. Click on 2 points wherever you want them, and then it'll create the line for you. Bada bing, bada boom. It'll be perfect. You'll say, man, my teacher's lines don't even look anything like that because she is a terrible artist. Maybe you'll think that. Maybe not. Yeah, so how do you feel about that? I guess I should ask once in a while. I just assume you stop me, but I don't know. Some people might be waiting for me to ask. You feel like it makes sense? It's not easy. I always think graphing lines is something that's it trips a lot of people up, and I think I was one of them as a student. Yeah. I think part of it seems like, what's the purpose? But secretly behind closed doors, it's because there are infinitely many solutions. X could be something and Y could be something. That's one answer, but there are infinitely many of them, and I can't list them all. I only live for a finite amount of time. I can't sit here and write an infinite number of things. So that's yeah.
Yeah, sometimes like we'll be dealing with graphs or whatever, and somebody homework. How many points do we need to do before we discern whether something's a parabola or just a straight line? Sometimes it's obviously just intuitive by looking at the equation, but other times it's not so, like, especially if we're just learning this stuff, you know. So.
Oh, that's a good question. That's a good question. You're right, huh? I think, let's see. I think if you just see an X and a Y, there's nothing, no interesting stuff going on with them. There's no absolute values. I know you might have kind of skipped over that, but if you saw, we'll see this a little bit in chapter 2 if we go a little deeper, but if you saw these lines around X, now that's not going to be a line because, I mean, there are lines next to X, but it's not going to, the graph's not going to be a line because there's more going on. Just, you know what I mean? Y equals mx.
Yeah, I'm familiar with the absolute, so that it always takes a negative and just makes it positive again.
Nice. That's something that supposedly everybody learns, but I don't remember learning that in high school. So if you know that already, then you're going to be, you're ahead of the game. But a parabola, you'll see those guys have an exponent on X. So if X has a second power, then it's a parabola. And I think we'll see that. Is that chapter 2? No, I think that's the beginning of chapter 3.
Yeah, maybe. I don't remember specifically, but there was one in particular where it gets a little bit tricky for me discerning. I was like between a parabola and then the V shape, you know?
Oh,
I mean, I know the general rule is usually if you see a power of 2, it's usually going to be a parabola, but
You're right. That might be worth just mentioning here because one of the sections in chapter 2 talks about all the different kinds of graphs. I can't remember exactly, 2.4. I don't know.
I believe it was 2.4 when it goes over all the graphs and stuff like that. Nice.
Okay. So even if you're not there yet, because those sections aren't due yet, but it could, hopefully it'll help, by the time you get there, you'll have seen it. So if you see like the ones we were just looking at, y equals mx plus b kind of thing, where m is a number, b is a number, then it's a line, of course. But then like you said, the absolute values, if you ever see absolute values on X, then it's going to be, like you said, the graph is a V shape. Yeah. Some kind of a V shape. I didn't draw it very well, but it's supposed to be like a perfect 90-degree angle inside there. Yeah, I'm not a good artist, but you know what I'm trying to do here, hopefully. And then if it's instead of absolute values of X, if it's X squared, that's the parabola. Oh, so we'll draw that. And then if it's X cubed, it's even something different. So right at the first few sections of chapter 2, you don't need to know all that yet, but once you get to, I think it's section 2.4, like you said, then they're going to start having you try to memorize these graphs and then do different things with them. Yeah, so if you see an absolute value, you just immediately memorize, oh, it's a V shape. If it's the X squared, then it's like this kind of like a U shape, but they call it a parabola. And then X cubed or X to the third power, it looks a lot like a parabola, especially the right side. Oh, and it's almost like the left side fell down. I think of it in the middle at the origin, there's a hinge, and it's like the right side hinged down. It's not tight anymore. It fell down or something. And what else is there? I think one more that you'll see in that section. Don't worry about this yet if you're just in section 2.1 or 2.2, that kind of thing. But you'll get there in 2.4. It'll be, and then square root of X, I think that's the last guy. So it will have you try to memorize these guys and then do different things with them. So that one, it looks like, just kind of starting from the origin, it looks like something's, you shot off a firework or something and it's flying that way. Those are kind of the basic ones that aren't lines. I mean, we're kind of mastering lines already in this part. But once you have lines mastered, then these are the other ones that, we'll kind of look at in that section. And then we're going to focus more on the parabolas in chapter 3 also. Lots of good times with those guys. You're going to look at them so much, you're going to hate them. Oh my gosh, I don't want to see these ever again in my whole life. No, it won't be that bad. But those are the basics. Yeah, that'll be section 2.4. That's good times. And like I said, if you have extra time right now, you don't have a lot going on, you can always get ahead in the homework and do them early, because now the first, I think 5 weeks should be open. Just if you want to, no pressure, you don't have to. But especially if you know something in Math 111, there's homework coming up and next weekend you'll be out of town or you're working or something, you can always get ahead if you want. Yeah. Okay, now what are we doing? Sorry. Those graphs. It'll, in section 2.4, those graphs will be given to you as if you've never seen them before. So you don't worry, don't stress about, oh, I should already know that before I go into that section. It'll be introduced brand new in that section. So don't worry about that. Yeah. It'll be good. Okay. So what else was there? I feel like maybe I was also too ambitious in all what I was trying to get through today. Let's see. We got slope. Okay. Now, wait, has there been a your turn yet? Oh. There. How about this? Oh, okay. Finally. I felt bad. I feel guilty. It's been me babbling on for almost an hour here, and everybody's like, "Can I do something? Can I try something?" I mean, it's kind of, I feel selfish. It's like forcing someone to watch you play video games. You ever had a friend that does that? Is there, you want to come to my house and play video games? And you're like, "Oh, okay. And then just make you watch them the whole time. Like, can I have a turn? This isn't fun. It's very similar in math. Okay. Something like that. Do you want to try? Okay, so this one, it's not really asking you to graph. I mean, I think if you're done doing what they ask, then you can graph if you have extra time if you want to. But all they want you to do is find the slope and y-intercept, which really that just means try to isolate y, kind of like we did, to where it's y equals mx plus b. Maybe we'll take a minute and try that before we move on and then try something else. Okay, I'll give you a few minutes for that. So do you want a few more minutes or do you feel like, how do you feel about it?
Okay, yeah, I mean, I'm not here off pretty long.
Do you feel like, anybody feel like they need more time or do you want to just go over it?
Yeah, I can make an attempt.
What's that? Sorry.
Yeah, I can go through an attempt.
Okay, I don't want to rush anyone if you're still working on it. Okay, okay. But also I was thinking, if everybody's all done, they're just like, okay, hello. Is anybody, yeah, what are you doing? Let's see. So this one, you're just trying to isolate Y, which, yeah, it's very strange because you don't know what X is, you don't know what Y is. It feels like you can't, but we're kind of doing what we did in the previous example where I want to isolate Y. So I would move the X term over first. That's what I want to do. In the last one, I think it was a 3X, right? This one is just an X, so I'll move it. Since there's no negative sign in front of it, I just assume it's positive, so I'm going to subtract it over. That way X is all gone from the left side. The negative 3Y is still sitting there. And on the right side, I'm going to put, let's see, there was a negative 6, but now I'm subtracting X from that. And I think a lot of times, the more times you do this, you remember, oh, you know what? I want the X term on the left and the non-variable number, the constant term on the right. So you might switch them either now or at the very end. It's up to you. But we'll get used to that to where when you're trying to isolate Y to get the equation of a line, so you can see the slope and Y-intercept, it's better to have X on the left. Okay, and then the last thing is there's a negative 3 being multiplied by Y. So I'll do the opposite and divide all the parts by it. And like we said, it's better individually. On the right side, there are 2 separate terms. I can feel free to distribute it and give them their own denominators or their own division to make it simpler. And I'm seeing that everything's negative here. There's a negative divided by a negative on the left, so it becomes positive Y. The first term on the right side is a negative divided by a negative, which is a positive. And I'm just for now, I'm just going to write it as X over 3, but I think it's kind of tricky. I'm going to think about what kind of slope that would be. And in the very last term, it's a negative 6 divided by negative 3, which is positive 2. So that one's not so bad. Why can't I write 2? Yeah, there you go. But if someone asked, what's the slope? I can't really see. It doesn't look like X times something. It looks like X divided by something. This is kind of tricky, but you can always, it's almost like you're cheating, but it's not. Instead of X divided by 3, you can think of it as 1/3 times X. It's kind of a trick that I don't think, if I'd never seen that trick, I wouldn't have thought to do it. But once someone showed me, they said, oh, you can write it that way. You're kind of trying to extract a coefficient out of X. So yeah, like I said, instead of dividing by 3, think of it as multiplying by 1/3. That way you're extracting the slope. Now it's a coefficient. So I know slope is 1/3 and then the Y-intercept now, yeah, is 2. So that one, if you wanted to, you can graph it, but you didn't have to. That was if you wanted to, just if you had extra time. But if you did, just to check, it would look like you'd start with the Y-intercept. So I do start at Y equals 2. Okay. Yeah, so wherever you put 2 on there. And then the slope is 1/3. So from there, I'd rise 1. Since 1 is positive, I'm going up 1. And then 3 is positive also. I'm running 3 in the positive direction. So it should look something like that-ish. From positive 2 on the Y-axis, I rise 1 up and run 3 to the right. So it's not a very steep slope. It's pretty shallow, I guess. That's because the slope is a small number, 1/3. Yeah, and it's sloping the correct direction. I noticed the number is positive 1/3. So I should be sloping upward from left to right. And it does look like that. So that's probably a good check. I think I did it right. Yeah. How do you feel? Any questions on that one now that we've kind of gone over it? Does it make sense? It's easy to make a mistake, or I don't know. It was hard to see what the slope was, I think, for sure. When you see it like just the X over 3. That was tricky. Oh, geez, what the heck? It's like the whole page just changed. Okay. Yeah, going from the X over 3 to 1/3 X. That's something we hadn't seen today or last week. So it's kind of tricky, but yeah. And like I said, I don't think I would have thought to do that as a student, but once I saw that from my instructor, then I tried to remember that from then on. Yeah. Okay. But any questions before we move on? I think we don't have too much left. We're just going to kind of take it easy. Okay. Well, no one asked questions, but please stop me if you have any questions. Either put something in the chat, yeah, or raise your hand, or just unmute yourself and go for it. Whatever you want to do. So now I think kind of the last topic here in this worksheet is, what if, and so far we've been given the equation. Here's an equation of a line, whether it be in the right form, Y equals mx plus b, or it's not in the right form. Either way, we are able to get information out of the equation. But this is where, excuse me, if someone's giving you information about the line, but you don't know the equation, then that's a little tricky. So this is when, yeah, the equation is unknown, I guess, and we have to go find it. It sounds like it would be difficult, but it's not too bad. Yeah. But so far, like I said, we've known the equation, it's been given to us, but we had to do something with it. So here's an example. They said, what is the equation of a line that has slope -2/3 and goes through the point 9, 2? I mean, I could graph it. I don't really need, like I said, I wouldn't need to find the equation if I just wanted to know what the graph looked like. I could just draw that point 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, okay, there's 1 point on the line, and then I slope negative 2/3. So from there, I'm going down to right 3. So it'd be something like, I don't know, something like that. Oh, okay, that's what it looks like. Bada bing, bada boom. I know what the graph looks like, but if I want the equation, okay, then I have to do some work. But it's not too bad. Yeah, they've given me the slope, negative 2/3. Okay, that's not so bad. Oh, it should be already working. Oh, there we go. Negative 2/3. Okay, and then there's a point on the line. It's not the y-intercept, obviously, because it's not on the y-axis, but still, that's enough information to get the equation. So like they're showing you, you just take the kind of the general equation of a line y equals mx plus b. And really all we need to know is b, because in order to know what the equation of a line is, I just need to know m. I'll fill it in like if I'm, yeah, in this one I'm given m is negative 2/3. I put it there, replace it. If I knew b, the y-intercept, I just replace it, and then I have my answer. Y equals whatever whatever m is. In this case, we know, blah, plus, and then b, I'd put it, and then I'd be done. I know the answer. So really, all we're missing is b. If I knew that, I'd be in a good place. But what I can do is just replace what I know and then solve for b. So this number, negative 2/3 is m. I'm just going to go ahead and replace it. And then in the point, the 9 is the x value. So I can replace x with 9. The 2 is the y value. So I'm going to replace y with 2. If I do that, I know everything in this equation except b, and I should be able to solve for it. So that's pretty much it. It seems kind of tricky. Seems kind of, I don't know, not cheating, but I don't know, kind of clever, I guess. So y is 2, and that's, yeah, again, because in that point, the y value is 2. So I'll say just replace y with 2, okay, and then equals m. I already know that. They gave it to me, and x, they gave that to me, so I'll replace that. B, I don't know, so I'll just leave it as b. But once I fill everything else in, I should be able to solve for b. Let's see, we said m is negative 2/3, so I'll replace that. And then multiplied by x. X was the x value of the point 9. So that's pretty much it. I just need to, now if I solve this equation for b, then I'll have the answer. Okay, 2 equals, I got to think about this. So I have a fraction, negative 2/3 multiplied by a whole number 9. I need to really multiply by 9/1. I don't know how to multiply a whole number by a fraction. So I have to create a fraction out of the whole number by putting it over 1. And then, like we said before, you can kind of simplify diagonally. So the 2/3 doesn't reduce. There's nothing that divides into 2 and 3, but 3 can go into 9 3 times. So it ends up being in the numerator, negative 2 times 3, and then the denominator is a 1 times a 1. So, okay, let me kind of go down here and continue working. So the 2 is on the right side. That's just kind of, he's waiting to see what happens on the right side. We have negative 2 in the numerator multiplied by 3. Oh, negative 2 times 3 is negative 6 over, and then I guess technically the denominator is 1 times 1, so 1 plus b. That guy's just sitting there. He's also waiting to see what happens here. 2 equals, and then negative 6 divided by 1, that's just negative 6. Okay, and now I can solve this for b, and then the answer is done for me. Because like we said, if I want to know the equation of a line, all I have to do is fill in m and fill in b. We already have m ready. I just need to put whatever I get for b now that I solve, I'm going to put it right there, and then I'm done. So if I want to isolate b, I guess I'd move the 6 over, but it's a negative, so I need to, I need to add it. The negative 6 and the positive 6 will cancel. The 8 is now on the left side, and so now I know b. It was a mystery, and now it's no longer a mystery. B is 8. Bam! I got the equation. There it is. Seems kind of strange, yeah, because you're usually given the equation. I don't have to go finding it, but this time they gave me all this information about what the graph looks like or what line it goes through, what the slope is. I have to find the equation. But really, like I said, all that comes down to is find m and find b, and then you're good. Just fill them into y equals mx plus b. So that's, yeah, that's the idea. And you might see that, I think in, what section in chapter 2? I think section 2.3, 2.2 maybe, I want to say. So this is good that we're doing this. It's just in time because that homework's due on Wednesday, I think. Yeah, so that's, I don't know, if in case this is kind of a lot, to find the equation, oops. The equation of a line, equation, you know, if you're given the slope and a point, a point on the line. Okay, how do we do it? We fill it all in. First, fill in what you know to that y equals mx plus b. You should know an x value and a y value and an m. Y, x, and m in y equals mx plus b. So you do that, yeah, like we did. You know everything but b. I know x, I know y, I know m, because x value, y value from the point, and then m was given, and then solve for b. You just kind of simplify what you got, like we had a fraction times a whole number, which was kind of complicated. But once we had that, then we solve for b. And then once you solve for b, you're good to go. Now I just replace the m and the b in the equation y equals mx plus b with what I know. Replace m and b in y equals mx plus b. Bam. And then you got it. That's the equation. So it's not, I don't know how intuitive it is. It's not like I would remember how to do that probably, but what are you gonna do? That's the idea. So hopefully that makes sense. Let me see. Now, please stop me if you have any questions. It's complicated. I'm gonna try to leave those steps up in case you want to write them down. Because it's, yeah, if it's a brand new kind of idea and you've never seen that before, or it's been a long time, then I wouldn't remember how to do that. And I wouldn't have thought to do that. That's for dang sure. So this is another example. This one is a little slightly more complicated, and we might see some of these in, like I said, I think section 2.2 or 2.3. You might have already gotten there and just blasted through that whole section. I don't know. But if not, this might help. This is another way they could give it to you. That this type of example, if they give you 2 points on the line, it's kind of pretty much still the same process, but there's a little bit of an extra step. So they're saying find the equation of the line through, they didn't give us the slope, they gave us 2 points. That should be enough. I just have to do a little extra work. 3, 1 and 6, 2. So it's still the same idea, but I want to eventually fill in m and b. In the last example, I knew m, so that was fine. But this time I don't know m, so I have to introduce a new formula. You may have seen before, you may have not. But if you don't know the slope but you do have 2 points that you know, then you fill them in this formula. That's, oh, why isn't it working? Y2 minus y1. So pretty much the difference between the y values. You subtract the 2 y values divided by the difference in the x values. And this works because it represents rise over run. If you take 2 points and you subtract their y values, that tells you how high or how far apart vertically the points are. And then if you, in the denominator, you subtract their x values, that represents run, how far apart the x values of the point are. So that's why this formula works. And that helps me remember it too, you know. If I'm coming on to a midterm or final, I might say, oh man, how does that slope formula go? But if I just remember rise over run, then I'll say, oh, rise, that's the y, y value. So they should go in the numerator. And then over run, that's the x values, because that's a horizontal change. So, okay, that's the first thing I need to do is fill in these values to find the slope. But then once I find the slope, I can do the same steps that we saw in the previous example, and then we're all done. Geez. So let's go ahead and find the slope real quick. It's a lot of work, but and you got to be careful too. I think I wouldn't rush these problems because I'll miss a negative or something. But I think a good idea is to assign x1, y1, x2, y2 to these. I'm going to call, in the first point, the 3 is the x value. I'm going to call him x1. The 1 is the y value. I'm going to call him y1. And in the second point, 6 is the x value, but that's my second point. So I'm going to call him x2. 2 is the y value. So I'm going to call him y2. And then I'll kind of know where to put everything. So if I'm looking at the numerator of the slope formula, m should equal, first thing that comes up is y2. Which one did I call y2? That was this 2 over here. 2 minus, and then y1, that was the y value of the first point. I called that 1. So the numerator is just 2 minus 1. Okay, good stuff. The denominator needs an x2, and I assigned x2 to be 6. So I'll put that guy here, minus, the minus from the formula, and then x1 was 3. I called that guy 3. Okay, I just need to simplify that. That's 1 in the numerator over 3. Okay, so slope is 1/3. So it just needed that extra step. I needed to do that part. Now I can kind of follow the same steps from the previous example. Let's see, why isn't my mouse working? Here we go. Yeah, now follow the steps. The same steps. Okay. So I'll do, like I said, back to these steps. First thing was replace what I know in the y equals mx plus b. Now we're kind of where we started in the last example. I know the slope now and I have a point. As a matter of fact, I have 2 points. So I'm even in a better place maybe. So I can replace m, excuse me, I know m 1/3. I'm going to put him right there. And now the question is, what about y and x? That's supposed to come from the point, like in the previous example, but I have 2 points. So which one do I use? You know, I was given 2 points. Was it 3, 1 and 6, 2? And the answer is you can use either. You pick one, and yeah. So that's kind of the tricky thing. I think on math, I don't like to have choices. I feel like I'm doing something wrong when there's a choice, but either point should work. It's up to you. Point works. So you can call, yeah. Works. I like to work smarter, not harder, I guess. So I would usually pick the point that has smaller numbers. So I'll just pick 3, 1, because those are smaller than 6 and 2. So I'll say, 6 and 2, his only purpose was to help me find the slope. Now he's purposeless. You can go get out of here, okay, my friend? But I need you, 3, 1. You are going to save the day. I'll take 3 and 1 and replace those for X and Y. So yeah, we know now the slope is 1/3. And the point that I chose to use is 3, 1. But actually, if someone else chose the other point, if you kind of like 6 or 6, 2 better, if you do the process, it'll look different, but your answer will be the same as mine. So really, seriously, it doesn't matter which point you use. 3 is the X value, so I'll replace X with that. And 1 is the Y value, so he should go here. And then I just simplify from there. And this one actually simplifies kind of nicely. Let's see. I'm going to put that 3 over 1 and then cancel diagonally. These 3 just cancel diagonally. So the 1 on the left, and then this just becomes a 1. 1/3 times 3 is 1. Because you know, the 3's cancel, it ends up being 1 times 1 over 1 times 1. So it's 1 over 1. Nice. And then I'll solve for B. Move 1 over. Bada bing, bada boom. Okay. Nice. So 0, I guess. That's kind of weird. For some reason, whenever I get 0, I always think I did something wrong. But no, that's it. All right, now we're all done. If I just fill in all the M and the B with what I know them to be now. M, we found a while back that was 1/3. B is 0. So I guess I could put plus 0, but you know, that simplifies to just, you could just write Y equals 1/3 X. Bam, done. But it's, yeah, usually B is not 0. You have to put plus whatever B is or minus whatever B is. So wow, it's a lot of work. That's probably as bad as these problems get. If you have an equation of a line, this is probably the worst thing they can ask you to do is, here's 2 points, find the equation. It's like, oh, I dread those problems because they take forever. But they're not too bad as long as you're careful. So we don't have too much time. How about just in the time we have, maybe I'll have you guys try, I don't know if you could see it very good. This you try one right here. Where is it? Dang. See if I can zoom in a little bit so you can see it better. The one in the green here. It says find the equation of the line. Dang it, what am I doing? Calm down, take it easy. Find the equation of the line through these 2 points. It's 5,4 and 1 negative 4. And it even gives you what the answer should be. So how about, we'll give it maybe 6 minutes? I don't know, is that too much? Is that too little? Let's try that just because we're running out of time. So your points you're given are 5,4 and 1, negative 4. So try to do the same things we did. Where you find the slope with this formula. And then you put it in the equation of the line and then see what you get. Okay, I'll pause it for now. Okay, sorry if you're still working on this one, just only because we're running out of time. I'm just gonna kind of go ahead and go over it, but don't, if you're still working on it, keep going and then maybe check afterwards. But if I label things correctly on the slope, I think the fraction for slope formula should look like y2 was -4, and then minus y1 is the other y value 4, okay. So -4 minus 4, okay, and then x2, I labeled it to be the 1 from the second, the x coordinate of the second point minus x1 is 5. So I think it's easy to make a mistake in here if you miss a negative sign or a minus, or if you put the wrong number in the wrong place, kind of like that's easy to do. Switch, like if I switch these two, if I put, +4 minus -4, it would almost be right, except that my slope would be the wrong sign. It should be negative when it is, when it's actually positive or vice versa. Okay, I'm going to get -4 minus 4, that's -8 over, okay, 1 minus 5 is -4, which looks bad, but then it simplifies down to a +2. Okay, whew, that's nice. Sometimes it's a nasty fraction and you just got to go with it, I guess. Especially in real life, like if this was some real life situation and I wanted to find the equation of the line that modeled, I don't know, something in real life, like how many boxes of cereal, I think we have an example in the coming section about that. Boxes of cereal are sold depending on how much advertising a company does, whatever. Usually the answers aren't nice, like the slope is a terrible fraction or terrible decimal, but they just try to make it look nice, I think, just because it's already hard to understand this stuff, let alone make the numbers terrible. So now you're free to choose whichever point you want to plug in for X and Y.
Sorry,
and
sorry,
sorry.
Professor. You made an incorrection. So
Oh.
you put 1 minus 5. It should have been 7 minus 5.
Oh, shoot. Was it? Oh, no, let me see. Oh, my God. I wrote the number down wrong.
Yeah.
Is it 7?
Yeah. So 7 comma -4. So x2 minus x1, that's 7 minus 5 instead of 1 minus 5.
Oh, but I think it's a 1 here, isn't it? Here?
No, you put a 7 comma -5. 7 comma -4.
Oh, you know what? I think it's probably because I wrote it too quickly. I'm sorry, but it's supposed to be a 1. I'm sorry. The actual example does say 1, and I think I just wrote it looking like a 7. Sorry, it should be a 1. I'm sorry. It's over here, buried under all this stuff, but it's over here. I'm sorry. Here, so I think if it was a 7, you probably get a fraction. That's probably not nice, huh? If it was a 7, oh no, that would be all right, huh? 7 minus 1, sorry, 7 minus 5 would have been 2. Okay, it would have been a nice number, huh? It would have been -4. So if you got -4, then you did it right, because my number did look like a 7, but it was technically supposed to be a -1. I'm sorry.
I have a question, Professor.
Oh yeah.
Yeah. So when we're doing the y2 and x2 and x1 and y1 values, determining which one's 1 or which set is 1 and which set is 2, is it just in what order it comes in the problem, or is it which one comes first, like on the graph? Like if you were to read the graph
Oh.
left to right, you know what I mean?
Yeah, good question. So for me, I always just say whatever point was given to me first. What they wrote 5, 4, so I'm going to call that my first one. But actually, it doesn't matter. So if you were to label it backwards, if you said 5, 4 is my x2 and y2,
Yep.
and my 1, -4 is my x1, y1, it would look different. Like here, for the slope formula, it would look a little different at first. It would be +4 minus -4. So you'd actually get +8. And on the bottom, you'd have 5 minus 1, but you'd get +4. Either way, though, you get the same slope. So that's kind of good, no matter which, how you label them. As long as the 2's are together in one point and the 1's are together,
Right.
it actually doesn't matter. It's kind of awesome. Isn't
Yeah.
math awesome? And
Yeah,
sometimes.
I had gotten that doing it that way, but I wasn't sure if it was just a coincidence that we got the same, so I wanted to verify.
Yeah, good question. I'm glad you asked that, because someone else probably wondering the same thing, is there a certain way I have to label them? But yeah, mostly it's just because I'm lazy and I don't want to even think about it. I just say, hey, this is the one given to me first, so that's x1, y1. This is the one given to me second, that's x2, y2, bada bing, bada boom. Yeah, but it should work either way.
So
And this-
Professor, can I change the 7 to a 1, or do you want me to just leave it as a 7?
When you upload your answers, you can just do it as a 7. That's fine. I'll just keep that in mind. When I'm looking over it and grading it, I'll just say, oh yeah, that's right, it was a 7. So yeah.
Sure.
Yeah, if anybody did that, you can just upload your version with a 7, because yeah, that one did look like a 7. And now I have to choose the X and Y. Sorry, I know we're a little bit over time, but if you have to log out for something, then I'm still recording this. So if you can come back and see the recording later. If you have to go to see it, do another class or whatever, it doesn't really matter what point you use at this point. You can use one with larger numbers or smaller numbers. I don't know. Even though the first point has larger numbers, the second point has a negative. I'm not a big fan of that, because I think with the negative, I'm more likely to make a mistake. So I'm going to choose 5, 4 to be my X and Y, but you should get the same answer no matter which point you use as your X and Y. So my slope, okay, was 2. I just found that. And I'm replacing my X and my Y with the values in my point, whether it's the 4 and the 5 like I'm using, or you could use the 1 and the -4. The process might look different, but your answer should be the same as mine, no matter which point you choose, as long as you're careful. Yeah, positive numbers are always nice, even though they're kind of large. That's no big deal. So I'm going to go, slope is 2 times X, which is 5. That's 10. So we almost have B. We're almost done. I'm going to move that 10 over. Aha. So B must be -6. Okay. So we're pretty much done. I just need to fill in what I know. I need to fill in my M and my B, and then I'm done with this problem. M was 2. Yeah, right. X plus -6, or I can just write -6. Either way. Whew. Okay, we did it. We're all done. Okay, I'm all done. Anything that was left in this worksheet, you can kind of skip because we didn't quite get to it. So if you just upload you try, or what do you call them? Your turn examples, but I think we only had 2, huh? If you just upload those as your problems, then that's probably fine. So if you want to log out, you're all good. And then I'll call it a day for today, but I'll stay and answer any questions if anybody has any questions. Otherwise, have a good one, and I'll see you Thursday. More fun.
Okay, Professor, I have a question. So a lot of these now you tries these worksheets for Math 33 live lesson, do we get, you said on, on the introductory, Zoom that, we get these PDFs from Library Center at MJC?
Oh, these ones, they're linked on Canvas, but the notes that you take when you do the videos for Math 111, that big PDF packet is in the library. I mean,
That's what I'm saying. Like the
Oh.
PDF, the worksheet that you're showing us right now, for example, this is, at the library, correct?
no, these are all they are is linked in Canvas. There's no physical copy of them. It's just for Math 111, the worksheets that I'll go, or sorry, the problems I go over in the Math 111 lectures, that PDF is in the bookstore, but these are not. These are just on Canvas.
Oh, okay. Well, I thought you said these are also in the library too.
No, just the notes packet for Math 111.
Professor, where is the, you said they're in the library for Math 111. Where's that at?
Oh, they're in, oh, sorry, they're in the bookstore.
I mean, the bookstore.
Yeah, they're on the
Where do you
east,
find that?
it's on the East Campus. There used to be a bookstore on both campuses, unfortunately.
Oh, it's
now-
actually at the actual bookstore. Okay.
Yeah.
Okay, sorry. I'm not very tech savvy, so I thought it was something like in Canvas, but I was mistaken.
Oh, no, that would be good too. Well, if you want, I can always, I think the big PDF is linked in Canvas in Math 111, but if it's not, I can email it to you. If you can't find it and you just want the PDF, if you don't mind, email me and ask for it, and I could just send it to you. If you'd rather have it that way than the physical copy.
That would be awesome. Yeah. Okay. I'll email you. Thank you so much.
Yeah, no problem. Thanks for asking. See, oh, and sorry, Dimitri, I see you asked about the absolute values. We didn't quite get to those absolute values, so you don't have to do that part. You don't have to upload that for this worksheet. I guess I made a calculated decision that absolute values, you don't see them very much in Math 111, so they're not super important. So I just skipped those, but I know graphing lines is a big part of it, so I just kind of focused on that today. So don't worry about the absolute value stuff. You can kind of skip over that if you want, or do it for fun if you want to.
Professor, sorry again. I want to have a word with you. You have an open office hour today, right? Between 1 to 3 p.m.
Yes, yeah.
Is it virtual or is it physical?
Oh, virtual, yeah. Tuesday, Thursdays, virtual, and then Monday, Wednesday, I have a physical office hour.
Okay, yeah. I just wanted to talk to you about, this issue that I've been emailing to you regarding
That's
the
right.
homework assignments, because I'm just really tensed right now because I feel like I'm just gonna fail in your class because there's no way on earth I'm gonna be able to complete these previous sections, if I can't even, sign in through Pearson, and I try to go on Pearson support, I can't find their phone number and things like that. And, I'm just really, fed up for the, out of all of this. So, I really, you're my last hope, and I really wish you can just help me out over here. So, yeah.
Yeah, I understand. I'm gonna, if you don't mind, maybe right now while I'm thinking about it, I'll put the link to the Pearson help in the chat. Let's see.
Yeah, I mean, it would be good if we find their phone number if there's a customer chat. Because,
Yeah.
you know, it's just, I can't, I just can't, because when I click on Pearson chat, it takes me to articles saying, what issue resonates with you? Pick the article that resonates with your, with your
Oh.
situation. And then it's like, I go over there and it tells me to try Google Chrome. I've tried Google Chrome and you have emailed me, right? Yes, saying
Yeah.
that try Google Chrome, and I've done that, and it still says your account is locked. I even try to, make sure some web cookies or drop-ups are open too, because it tells me on Google Chrome,
Oh.
when you use a different web browser like Google Chrome, make sure that the drop-ups that you're using that on Pearson is going to be open. Make sure it's enabled. It's enabled. Everything is all set. And yet and I've tried Firefox too, and it's still saying my account is, locked. So I've tried 3 different browsers, but my default was Safari. And
Okay.
it's just, I don't know,
So-
Professor, but I'm really stressed out over here. So, I would really appreciate it because I'm trying to excel in your class and I don't want to lag behind. So this shows that I really want to put a lot of effort in your class and care so much. So, out of this
Yeah.
consideration, I'd really appreciate it if you can do something, really, I appreciate it.
Yeah, I understand. So I wish that I could control who's locked out of their Pearson account and who is not, but I'm not, unfortunately, I'm not able to do that. Only Pearson can do that. And in the chat, I put a link to how to contact the Pearson support. I don't know if you can see it. And right now I'm sharing my screen, and this is what I see. So when I go to that link, I filled in, the country we're in, and then what else? What else do they want? Whether you're a student or you're or whatever, or whatever. And then what's the issue related to? And I put access code. And then on the right here, there's a link. Do I want to chat or do I want to talk on the phone with someone? So now I just have to click on one of those and it's going to get me talking to someone.
Wait,
Can you
click on the phone just to see, okay, thank you.
Yeah.
Okay, this information.
Oh.
Okay, so we have to give them information for them to call us.
I guess, let's see. Is that what it, I actually never done the calling. I always do the chat. Oh, shoot. I messed it up. Come on. I think because calling, I just figure that takes a while. But
Yeah, you know why I prefer the call, professors? Because when I do the chat, I fear that it will just be a robot, talking with me, and it's just going to take a waste of time. So that's why I rather prefer, chatting with an agent, instead, so he can get me. And to be honest, I know my Pearson account. I didn't create anything because here's why. I was in this online educational platform during my last 2 years in high school called California Connections Academy, if you know what that is. So California Connections Academy paired with Pearson, with a British online educational platform during my senior year. So it's funny because my username and my password that I used to log in to my Connections Academy, account, as the Pearson, because they both paired together. They both work together. So I can, you understand what I'm saying, right? So
that makes sense.
for that reason, this leads me to my next question, because since I'm done with, California Connections Academy, therefore, AKA Pearson, do you think that's probably why it's saying my account is locked? Because
maybe it has something to do with that school that you're no longer attending, or I don't know. That's a good.
Yeah, that's what I'm saying. Do you think that it has something to do with that?
I think it might be. I see now that I'm trying to chat with someone and it says, "Hi, I'm the Pearson virtual assistant." I don't know if you can see it on my screen, but it says,
I can see it.
okay. But it says here, to speak to an agent at any time, please select transfer agent from the menu at the bottom. So I'm gonna do that. Let's see how it works on. If it works, then maybe you could try it, but if it doesn't work, then we'll think of something else. Let's get you to someone who can help. Okay, first, what is your username? Okay, now it wants you to type in your username and all that. So it probably will work. I think you just have to, at first it'll give you a robot to talk to, and then it'll say, if you want to talk to a person, put transfer to agent. And then I did that. And now it's saying, what's your username and password? And then I think an agent will talk to you.
Yeah, see, that's what I don't like, to be honest, because I just feel like because this isn't the only time where I've been stuck in with a robot in any customer support service,
Yeah. I'd say it's either probably try that, hopefully chatting with the agent works and it's not eventually it's not a robot and you actually get solutions, or you might just have to create a brand new Pearson account and go through that way.
Okay, so Professor, where it says product category, do I click on printed books or digital or online products?
I think the digital online, yeah, because that's just my math lab access code. You don't need a textbook. Yeah.
Okay. So I'm on the same thing that you're at right now. I clicked on contact us,
Nice. Okay.
country, say United States, role, English. Okay, wait. College student, issue category. So when it says issue category, do I click on sign in or password?
Yeah, that's probably a good one. I think that's the perfect one.
Okay. Product, it's asking me for product. What do I click on? Course
I think
Connect.
I searched math and you want my lab math? Is that what it said? Oh, shoot.
Math lab.
Yeah, there you go. There you go. That's the one. I forgot what it was called. Thank you.
Okay, I can't find that in the
Oh.
drop-down list.
Let me go back. I forgot what is exactly what what did they call it on there? They didn't exactly call it my math lab, huh? Come on. Wake up, guy. Okay, blah, 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 blah. I'll try to do it again so I can see. Okay, course of study, college student, okay, issue category. What was it? Sign in. Oh yeah, where is that guy? There it is. The very last one, of course. Okay, I searched math. Okay, I think it says my lab math. That's the one. Yeah,
Okay, hold on for a second. Let me.
yeah, no problem.
My lab math. Okay. Okay, so now I see where it says start a chat session with a Pearson support now, or available Monday to Friday, 10 a.m. to 10 p.m. Eastern time. So that means 7 a.m. to 7 p.m. Pacific time.
Yeah, right. I think so. Yeah.
Let me see if I can click on call us, put my first name, last name. Six 506602988. My desk here near.
How's it looking? Is it looking good?
That's hold on for a second.
Okay. Yeah. No rush. No rush.
Okay, so I see it says here's the phone number. Call us when you're ready. Reference this case number when you call.
Oh, interesting. Okay. Huh. I wonder why they do it that way instead of just connecting you with someone right there. It's kind of
And,
interesting.
and you know what's funny, assuming that it had something to do with the fact that I don't go to that online school anymore, which is probably why that it says my account is locked. I try to create a new account, but then it's gonna ask me for a different email address, a different information, and I'm not gonna do all of that. So
Oh, right. That's true. You have to create a brand new email just to get an account.
I'm not gonna do that. I'm not gonna do that.
Seems like you shouldn't have to, right? I think they should be able to fix it. It seems like
Yeah.
just unlock it. I mean, how big a deal is that for them?
I really don't understand, but yeah, so I can either click on chat or phone, right?
Yeah, yeah, kind of depends what you prefer, but yeah, see how it goes. Hopefully it goes well. I'd say try to call, like you said, and if that doesn't work, maybe then try to chat.
Yeah.
Call seems like a good idea. It's probably quicker.
Yeah. Okay. Well, thank you very much, Professor, for
Yeah.
showing me this. And if
No problem.
all else fails, I'll try and come in between 1 p.m. to 3 p.m. and let's
Yes.
see if we can come up with another, solution or idea.
Yes, please do. And if it works out, please let me know. Email me because I'll be worried about it. Just let me know. Hey, it all worked out. It's all good. If you don't mind.
Okay. Okay, Professor. Thank you very much.
Yeah. I hope that's the case. Sorry about that. That's a pain.
No problem. Is this like,